Today we are going to learn how to build a model for detecting ships in a sea view. So we will take hundreds of images of ships and then build a model, train it, and then we will take a test image like this one, and we will run our model through this image and detect the boats on this image, as you can see here in these results. So this is part of a playlist of object detection. Here is the link for this process. Okay, let's start with the installation. As always, I will leave a link in the description for the full code and all the instructions files. And always I have one video that contains all the installation process end to end. But as for now, I will give you a short brief about the installation. So first of all, you have to create a new Conda environment. As you can see, I will name it YOLOv8 and it will be based on Python 3.8. Then we will activate our new environment. Next, we have to double check what is our CUDA version. In order to do that, we have to run a command prompt with this command nvcc ---- version. I'm using CUDA 11.8, so if you go to the PyTorch environment, PyTorch website and look for all the supported CUDA versions, you can find that this is the command for running PyTorch 2.1.1. Of course, you should install your relevant PyTorch that support your CUDA installation. Then you have to install the Ultralytics that contains the YOLOv8. I installed 8.1.0. And then you have to install this Python library that will help you with some manipulation with the data. The next step would be downloading our dataset. So we will go to step number 2. As you can see here, this is the link for downloading our dataset. So it's based on the Kaggle website. And there is also a recommendation for the YOLOv8. We have to do some rename to the subfolders. But first of all, let's go to this website and let's open our browser. So this is the dataset. And as you can see, we have here a train subfolder and a test subfolder. And if we open the train, we can see that we have images. So this is examples of our images. You can see that those are ship images. And there is also another subfolder that named annotations. And this is an XML file. And we will open this XML after we will download our dataset and explain how can we change or transform this XML file to a YOLO format. So let's download this dataset. Here we click here and download the dataset, and we will continue with this process after downloading the dataset and extracting the zip file. Okay, so I download the dataset, extract the zip file and copy it to my dataset folder and name it as ships detection. Now let's open this subfolder, and the first instruction is rename the JPEG images to images in lowercase in the training and in the test folder as well. So let's go to the training folder and we will change this one, JPEG images. Let's rename it to images. Great. And let's do the same for the test subfolder. We will change this, rename to images. Okay, now let's go back to our training dataset. Let's open the images folder, and as you can see, there are many images of ships. Let's open this one. We have here 2 ships, and here we have many ships, and here we have another ship, and here another ship. And let's go for the annotation folder. And if we go to the annotation folder, we will discover that we have these XML files. And once again, let's go for the images. As you can see, the image name is ge_1.jpg. So if we will go with the same name, ge_1.xml, and open this file, we will discover that it contains information about the annotation. So first of all, there is a general information, for example, the name of the file, the dimension of the image. So this is the width, the height, and the depth, so how many channels. And if we go here, we can see an object, and here in the object we have an object named boat, and this is the bounding box around this boat. So if we go for the next object, you can see that we have another bounding box. So we can understand that in this specific image, two boats were annotated, and these are the positions or the coordinates of the rectangle around those boats. Let's go back to the folder. Let's go back to our images and open the first image. And as you can see, we have here, this is the first boat and this is the second boat. So basically what we have to do is create a Python program that converts all these annotations to a YOLO annotation, and this will help us to run a training for this dataset. And then if we will choose if we take a test image, and we have here a test image, close this and close this, we have here a test image. I name it boat test. We are expecting to identify and detect all those boats in the image. So the first part would be creating this Python file that convert all the annotations to YOLO format, and basically I have done it. So we will cover the code, explain the code, run it on one image, and then run it for the full folder for all the images. Okay, now we will learn how to convert the XML file, the annotation file, to a YOLO-based label. So basically, if we look at our images, let's choose the first image, and this is our image. As you can see, it contains two boats. And if we go to the to the annotations library, you can see that we have a file with the same name, but the suffix is .xml. So let's open this file, and as you can see, these are the annotations of this specific image. You can see there is object with all the bounding boxes, and there is another object with all the bounding boxes. So we have two objects that are the annotations for these two boats. So what we have to do is convert this XML file to a YOLO label file. So I will leave this Python file that contains the process to convert all the files. But let's first of all start with explaining this short Python code. So we start with importing the necessary libraries for XML parsing and file operation, and then we will define a new function. Let's call it convert XML to YOLO, and then we will parse the XML file to extract the data structure. Then we will get the root element of the XML structure, and then we will extract the image dimensions from the XML file. We will continue with open the file in write mode to save the YOLO annotation, and next we will iterate over all the objects in this XML file. We know that we have two objects, so we'll iterate through all the objects that we will find in this XML file. Then we will get the class name and the corresponding index from the class indices dictionary. Next we will extract the bounding boxes. If we go back to our XML file, you can see here these are the dimensions, this is the object, this is the class ID, and here we have all the bounding boxes for this specific first object. And now we are converting all the bounding box coordinates to a YOLO format. Then we will define, here we will define the path for our XML file, and here is the path for our YOLO file. Here we can also define all the classes in our project. In our project it's very simple. We have only one class, which is in the place of 0. Okay, if we had two classes, we will have the next class and the position will be 1. And we also checking if our label folder exists, and if not, we will create one beneath the training folder. And then we are running our function. So basically what we are expecting to see, that this Python program file will create a new folder named labels, and inside these labels we are expecting to find one YOLO file with this name ge_1.txt, and inside it we will have two classes in a YOLO format label. Great, so let's run it. As you can see, it finished. Let's go now to our folder. So as you can see, we created a new folder named labels. Let's open this folder, and we have one txt file which is the labels of our two ships, and let's open it. And as you can see, we have two objects. Each of them is a boat. The boat is class number 0, and here are the coordinates in a YOLO format. Great. Now let's continue to the next step. And what is the next step? We have this Python file, which is basically the same, but the only change is that we are running it on a full folder, because we would like to change all the XML files, convert all the XML files to a YOLO format, and we will run it twice, one on the training images and XML, and the second time on the test folder. I will remind you, if I go back, we have here one folder named training and one folder named test, and each one of them has its own images and its own annotations. So basically it's the same function, everything is the same, and the only change is that we are running a loop through all the images inside the training and inside the test folder. This is the only change. As you can see, we are running a loop of all the XML file in our list directory. So let's run it as well. As you can see here in the training, all the labels were generated. Let's open one of them. Great. And if we go to the test folder, everything was generated as well. Great. So now we have images and we have labels in YOLO format, and now we are ready to start the training. As always, all this code will be in the video description, so you can download it and run it on your local machine. Okay, before we start the training, we have to define our data YAML file. It contains the basic information for the training. So let's create one. Let's name it data.yaml. And here we have to put the full path for the training images and for the validation images. So let's open back our dataset. Let's see, inside the training, all the images are here. So let's copy the full path. Should write train, and this is the full path in my local machine for the images. And next we have to type val, and we need the full path for our validation images. So let's go back here, test. Before copy the path, we have to rename it. It should be images and not any other names. The YOLO has a very strict rules about the name of the subfolders. So all the images are here. Let's copy the full path. Once again, let's change the direction of the slashes. Great. Next, we have to define the classes. So we will write names, and we have 0 boat, and that's it. Let's save it, and let's continue to the next step. So now let's start coding the training process. We will start with importing the YOLO class from the Ultralytics library, and then we'll define our main function, which all contain the code for the loading, configuration, and training. Then we are creating a YOLO model instance. We're using the YOLO8L, the large model configuration for representing the large variant of YOLO8. We specify a path to our data configuration file. This YAML file contains information our dataset, including path for the training and validation images, and also the class's name. Next, we will set up our project directory and experiment name. This is where our training results and model output will be saved. We will put it under our dataset main folder. Now we start the training process by calling the train method on our model, and let's break down all the parameters. Data points to our configuration file. Epochs sets the number of training epochs to 100. Name and project specify where we are going to save the results. Batch, let's say create a variable for that. Batch will define the size for training. The batch size 16 means the model will process 16 images at each time during each training step. Device will set to 0, which typically means using the first GPU. Patient's early stopping parameter will stop training if no improvement after 10 epochs. Image size sets the input size to 640 by 640, and verbose enable detailed output during training, and val and val true enables validation during the training. Finally, we use the standard Python idiom to ensure that our main function is only executed if script is run directly and not if it's imported as a module. So let's start the training. Okay, now it's imported all the training images, and now all the validation images. As you can see, about 700 images for training and 100 are the validation images. And now it's going to run about 100 epochs. Of course, we are not going to wait all the 100 epochs. Basically, it can stop earlier if there was no improvement after 10 epochs. Let's wait a few more seconds, and I believe that we will stop the recording and jump directly to the last epoch. So our training has finished. As you can see, it took 25 epochs out of 100. That means that this patient's equal 10 was relevant. So basically there was no improvement in the last 10 epochs. And also you can see here that these 35 epochs took about 5 hours. This is because we used the YOLOv8 large model. If you will use a smaller model like the 8S or the 8N, you can train in less time. But of course, in this tutorial, we would like a better accuracy. Also, we can see here that all the results were saved in this folder under my model. So let's see this folder and let's see all the results. So this is our dataset folder, and as mentioned earlier, we created a new subfolder named my model. Let's open this folder, and basically what we can see that we have here several images and also a subfolder named weights. If we will open this subfolder, we can see that we have two files, one named best.pt and the other one named last.pt. And these files contain all the weights of the training of our specific custom dataset. Last.pt is the last one that will save, the last epoch, 35 epoch, and the best.pt is the best results of all the 35 epochs. So in our test Python file, when we are going to test it on a fresh and new image, we will use the best.pt. Also, let's open this image, results.png, and you can see that we are expecting that all the training will go down. As you can see, it's a very good line on the training of the boxes, on here on the training of all the classes. It's a very good line. And also here in the precision, we are expecting that the line, the graph would go up, and as you can see, it goes up. So it's a good sign that our training was a good training. And let's also open some validation images. As you can see here, we have validation batch 0 and validation batch 1. Let's, for example, open this image, validation batch 1, and you can see here a bunch of test images. This, for example, is test 97. As you can see, it was detected very good. It detected the boat, and here in this image it detected the boat as well. And also in other images the detection is very good. So we are not seeing any boats that are not detected. So So this is another good sign that our training process was great. So we will move to the next step, which is choosing a test image, and we will try to detect this test image, a new one, a fresh image that our model never saw before, and we would like to see if the model draw a bounding box inside our image and detect the boats in the image. So let's go back to our VS Code, and if we see here, we have here an image named boats test, and you can see it's a complex image that contains many types of boats, and we would like to see if our model can detect those boats. So now we would like to test our model with a new and a fresh image. Let's create a new Python file. Let's name it predict.py, and we will start with importing the necessary libraries: Yolo for Ultralytics, OpenCV for image processing, and OS for path operations. And here we specify the path for our test image. So let's copy the path and paste it. Great. Don't forget to change the direction of the slashes. Then we read the image using OpenCV and store its height and width. And next we will create a copy of the original image to draw our prediction on it. And now we construct the path to our train model weights. So this is the path for the subdirectory, and beneath that we have weights and then our best.pt file. Then we load our trained Yolo model using the weights we specified. Then we set a confidence threshold for our predictions. Let's use a low value to capture a wide range of ships. Then we will run our model on the image and get the results. The first index is used because the model returns a list of results even for a single image. Now we run a loop through each detection. For each detection we extract the bounding box coordinates, confidence score, and class ID, and if the score is above our threshold, we draw a rectangle around the detected objects. We also add a label with the class name above the bounding box. So this is the function for drawing a rectangle. The arguments are the image, the rectangle coordinates x1, y1, x2, and y2. And then more parameters like the color of the rectangle, how thick a rectangle. This is part of the rectangle function. And then we will put a text, let's say 5 pixels above our rectangle. The text will be the class name in uppercase. And once again, these are the coordinates for the text. Let's put it 10 pixels above our bounding box. We also choose a font and how thick would be the text, and also the color of the text. Great. And after that, after the processing all the detections, we will display both our original image and also the annotated image, the one with all the prediction. Let's run it. Let's wait a few more seconds. So this is the original image. Let's make it smaller. As you can see, we detected most of the boats, the ones that are more similar for our training images. I hope you enjoyed this tutorial. You are most welcome to subscribe my channel. Thank you very much. Bye bye.